Hey everybody, this is your 7.5 Math Excel video, and as a reminder, the exponential graphs go up like this, and the logarithmic graphs also go up, but it's to the right of the y-axis. So remember that they would reflect across y equal x since they're inverses. So the first step on this one is you have 625 equal 5 to the 4th, and you want to rewrite it in log form. So think of this as the number equal the base to the exponent. So what that means is you change it to log of the base, because the base for the exponent is the base for the log. And then the number goes here, and then the exponent goes over here, where it says equal the number, or equal the exponent. So in our case, 5 is your base for the exponent, so you put 5 for your base for your log. 625 was by itself, and now it's with this, and then 4 was the exponent, so now it's by itself. So that's how those work. Okay, on the next one you have log base 2 of 8, and this would just be 3 because 2 to the 3rd power is 8. So that's how it works. You basically go here to this direction, and it's equal to that one. So kind of like a circle or as a snail. So the next one, log base 64, 16 equal 2/3. So you basically keep this where it is and do 64 to the 2/3. So now that would be true because if you have a fraction exponent, it works like this. So if it's 2/3, then your 3 goes here because the denominator is the root, and then this would be 64 squared. So you can do your cube root of 64 first and get 4, and then 4 squared is 16, which is why these are equal. On the next one, you have 64 equal 8 squared, and so then your exponent is the number by itself, so you just say 2 equal log base 8 of 64. Some of these are really fast and easy, some are a little bit longer. On the next one, you have 1 over 625 equal 5 to the negative 4. So then your negative 4 is the exponent, which is then by itself. And then you have log base 5 of 1/625. Now the next one, it's number 6. You have log base 2 of x, and then you go minus 4. It's basically down 4. Because it was not in parentheses, and that would have been right 4. In this case, you're supposed to choose the graph, and then you're given a certain domain, and the domain has brackets, so even though normally the range would be negative infinity to infinity, you're given a specific domain, and so you have to give the specific range also. Now what you know is the graph generally goes up like that, and so the 0.5 side would be here. So you have log base 2 of 0.5 minus 4, which gives you negative 5. And this one is log base 2 of 4 minus 4, and that gives you negative 2. So think of this as the ordered pair 0.5, negative 5. And this is the ordered pair for negative 2. Now remember on your calculator, the log is control 10 to the x, and you type your base. So like if you're on the calculator, there's the 10 to the x next to the 1. So you do control 10 to the x, and that's where you type in your log base, like base 8 of 64 is 2. So that's how you can do it. Okay, on your next one, you want to find the inverse of this, and you have y equal log base 2 of 5x. So since we're doing the inverse, the first step is actually convert it from logarithmic to exponential. Convert to exponential. And so since it's a base 2, then this is a base 2, and the y goes up there, and then the 5x goes here. After you convert it to exponential, then switch x and y. So you have 2 to the x equal 5y. Then you just need y by itself, so you're dividing by 5. So that's 1/5 times 2 to the x. The next one, you want to match the graph with the inverse. And this one has a little formula. If you have y equal a log base b of cx, then y equal 1 over c, so basically 1 over your coefficient times your base to the x over a power. So on this one we have log base 8 of x, so that means there's no number in front, and so think of the a as a 1, the b is the 8, and the c is also 1 because there's no coefficient there. So that would turn into y equal 8 to the x, and then you just find the graph. Then on this one, log base 5 of 7 to the x, again there's no number in front, so you keep a as 1, your b is 5, and your constant is 7, or coefficient. Your coefficient is 7. So that gives you y equal 1/7 times 5 to the x. And then you want to graph that. Now what I noticed when I did this is it was more to the right. Let me rewrite that. It was more to the right than the previous. And you could use your tables. Control T. Now on the next one we have log base 1/8 of x. So if the base is between 0 and 1, it's going to go backwards. Here we have a and c are 1, but the base is 1/8. And so it's like that. Number 9, on this one, log base 3 of 81 equal 4, and so we put 3 to the 4th equal 81. And then on this one, negative 2 equal log base 4 of 1/16. So the negative 2, which was by itself, is now the exponent. And since 4 was the base for the log, it's the base for the exponent. And the 1/16 goes here. Okay, next we need to find the minimum and maximum of two different logs. You have log base 2 of x and log base 10 of x on a given domain, which is bracket 1,000, 7,000, which means it includes those numbers. This is increasing, so the left side would be the minimum. So what you can do on your calculator is do log base 2 of 1,000, get your answer. Log base 2 of 7,000, that'd be your answer. So that would be your range. You do a bracket here, comma, bracket here. And then same thing on this one. On log base 10 of 1,000, well that's 3, because 10 to the 3rd power is 1,000. And so this would be bracket 3, comma, 3.845. So again, normally your range would be negative infinity to infinity, but you were given a specific domain. Okay, on the next one we want to write this in log form, and it's point, and you have 4 zeros in front of the 1, and that's equal to 10 to the negative 5. That is correct. It's a negative exponent, and it's closer and closer to 0. So to rewrite it, you put negative 5 by itself, log, and you're using base 10, and then put this number here. Okay, and then the extra practice B, log base 49 of 7 equal W. So then, it's really 7, 49 to the 1/2 equals 7 because the square root of 49 is 7. And so basically W is 1/2. And then the last one, it's just a multiple choice graph. All right, hope that helps.